Alright, this is the video for lesson 7.1 common logs. So we're going to find common logs, solve logarithmic and exponential equations, kind of like what you did in Unit 6, and use the change of base formula. So the first thing we need to find out is, what is a common log? So a common log is a log with a base 10. So this is the log that's programmed in your calculator. So programmed in calculator. So when you have your calculator and it's got a log button, it always has a base 10. And what you should know is when no base is written, it's a 10. So I say the invisible base is a 10. So the common log would be written like that. You don't normally write the base 10. So on your calculator, now my calculator is a little different. This is a TI Inspire, and here's my log button right here. So notice when you have the log button, it's a base 10 automatically. So now what do you do when you have a calculator and it's a base 10 calculator? Say something like this, which just has your basic log or even your TI-83, and you have a problem. Well, these are base 10. So these are going to be logs that you can just punch into your calculator and get. So your calculator always does the base 10, so you just have to find your log button, do log 6, and you're going to get a big long decimal. Directions here say shorten it to 4 decimal places. So you're going to want to do that. So that's just simply find the log button, punch it in on your calculator. Same thing here. Log base 10, 0.35, find the log button, punch it in on your calculator, and you're going to get a decimal. This one happens to be a negative. So these are no base, no base, no base is always a base 10. Okay, so what do you do when you have a log problem that has a different base, but you want to do it in your calculator? So here is the equation. So this is the in general equation. Log base b of a, so remember a and b will be numbers, is the same as log base 10 of a over log base 10 of b. So this is why it's called the change of base formula. You're taking a log with a base b and you're changing it to a base 10, right? This could also be written as just log of a over log of b, because the base 10 you don't normally write. So this allows you to rewrite as a log with base 10. Okay, now here's how I remember which goes on top and which goes on bottom. When you look at this, doesn't the A look like it's over top of the B? So what you punch in your calculator is log A divided by log B. So A over here looks like it's on top of B, so when you put it in the fraction, you put log A over log B. So here's some examples. Express each log in terms of common log, so that means base 10. Then approximate to 4 decimal places. So here I have log base 3 of 16. I want to find out what this is. I want to punch it in my calculator, but I don't have a calculator where I can do different bases. So what I'm going to put in my calculator is log of 16 divided by log of 3. So 16 looks like it's over 3, so you put in log 16 on the top of your fraction, log 3 on the bottom. So this is changing both of these to base 10. So if you put that in your calculator, you'd get approximately that. So remember when you're dividing with logs in your calculator to wrap them up in parentheses. That's usually a safe bet. Now I also want to tell you that a TI-84 will let you put in other bases. So on a TI-84, so we'll put that down there, you can use your math button, and you're going to go down the math menu until you see this menu item, and this will let you put this directly into your calculator because it lets you put in different bases. But if you don't have an 84, you have to do the change of base. So for this one, what you would put into your calculator is log of 50 over log of 2. This one looks like it's on top, so put the log 50 on top. Put that in your calculator and you should get something like this. So what I recommend you do is try these. Punch them in your calculator and see if you get those values. Okay, now we're going to be solving some problems. And you've done these in Unit 6, but these are logs that you cannot rewrite as exponentials. Let's wait for my camera to focus here. Oh, come on camera, come on camera. What's going on? There we go. Shoo. So it says solve the following equations. If necessary, round to 4 decimal places. Oh, geez. So remember, solve means find out what x equals. I'm going to try adjusting this a little, see what happens. Come on. Get my hand in there. Ugh, this is frustrating. Technical difficulties. Let's see if I get my hand up there, if that helps. Oh, that does help. Temporarily. Okay. Alright, so I want to solve. So remember, I want x equals a number. Now, if you try to find a common base here, there is no way you can write 62 as a base 5. So we cannot do what we did in Unit 6, where we found a common base. So there's no common base. So what we're going to do instead is we're going to rewrite as a log. Okay, so we're going to do the arrow thing, same thing like you did in Unit 6, but we're going to turn it into a log. Log base 5 of 62. So log base 5 of 62. Remember, first arrow is everything on the left side of the equal sign, equals x. Okay? Base exponential with a base 5 becomes a log with a base 5. Now this is a number. I can put that in my calculator. But if I don't have a TI-84, I need to use the common log. So first I need to convert it into a common log. So I'm going to write this as log of 62 over log of 5. And remember, when I say common log, that just means a log with a base 10. And that's going to equal x. So now this is a number I can put in my calculator, and what I get is x equals approximately 2.5643. Okay? So step 1, rewrite it as a log. If you can't do common bases, rewrite as a log. Then, once you get your log, if you have an 84, you can punch that right in the calculator. If you don't, then you're going to convert it to common logs. So put the one that looks like it's on top over the other, punch it in the calculator. So I'm going to have you try this one, and I'm going to tell you when you're done, you should get, oops, not 3, erase that, 2.5789. Try that. Same steps. All right, let's look at this one. Okay, so there is no way to write a 11 as a 7 to the something. So this is another one with no common bases. Right? We didn't give you problems like this in Unit 6 because you didn't know how to do them yet. So we're going to convert it to a log or rewrite as a log. That's your first step. So this is going to be log base 7 of 11. Log base 7 of 11 equals 2x plus 1. Okay? Can't punch this in the calculator because I have an old 83, so I'm going to rewrite it as a common log. Log of 11 divided by log of 7 equals 2x plus 1. This time when I get my decimal here, what I get from my calculator here is 0.1162. But notice I'm not done yet. I still have to continue solving for x. So I'm going to minus 1 from both sides. Oh, what do I get for that? I got to punch that in the calculator. 0.1162 minus 1 equals negative 0.8838 equals 2x. Divide both sides by 2. So just leave that number in your calculator, hit divide by 2, and I got something different than I have in my notes. Oh, I gotta go back here. Cross that off. Sorry about that. Log 11 divided by log 7 is 1.2323 equals 2x plus 1. There we go. Minus 1 from both sides. I get 0.2323 equals 2x. Divide both sides by 2. And I get 0.1162 equals x. So keep with the 4 decimal places. Okay? This is another you try. I'm going to tell you, you should try this on your own. And that is what you should get. X equals 1.0401. That is it for 7-1. Okay.